So in the last session, we have discussed about control statements. Like we have seen different types of control statements, conditional statements, loop, loop statements, branching statements, and we have seen the use of those statements. Now, in this session, we are going to discuss about arrays. So what are arrays? Array is a collection of elements of the same data type. So what are the arrays? We can define arrays as it's a collection of elements of the same data type. So we call that as homogeneous data. So array is a collection of elements of same data type. What does that mean? So say for example, today, if we wanted to store some value, what do? We usually declare a variable, some variable, and assign a value to it, right? Say for example, I need like the same value, like I wanted to store 10 numbers. So what can I do today? So a equal to 100, b equal to 200. Like this, I need to have n number of or 10 number of 10 like 10 variables to store 10 numbers, right? Say for example, I wanted to store 100 numbers. So in that case, I need 100 variables, right? So if you go on, if the number of variables are increasing, so the variables will be increasing, right? So it is a tedious job to actually maintain these variables. We know anyway all these are integer variables, and mostly these are like related. So in that case, so if these are grouped into one component, and if we are able to manage that, then that would be beneficial for us, right? So that is what arrays does. So as these are of same data types, we do have different elements. We call these as elements. So each one is, let's say, one element. So if we are able to group all these elements into one, as anyway these are of the same data type, so then that is called as an array. That is called as an array. It's a collection of elements. These are all elements of the same data type. If you observe, these are all of the same data type, integer. So not only integer, it could be any other data type, but if they are all of same data type, then we can group them and put it as one collection or one variable. That's what we call it as an array. So till now, what we did, see, so in one variable, we can only assign one value. So say for example, I have a equal to 100, then I can't actually say a equal to, say for example, so 500, right? So if I say a equal to 500, this will be overridden. 100 is no more available in a. It is overridden with value 500. So at any point of time, we can store one value in a variable, right? So we can't store multiple values into a single variable, right? So, but array allows us to store. So you will have only one variable declared, but still you will be allowed to store multiple values into it. So that is what an array can do. So let me show you the syntax of an array. How do we declare array? So this is how we declare a normal variable, right? So how do we declare an array is, after the variable name, we have to have two braces, square braces, open brace and close brace, which actually indicates that it's an array. It's not a normal variable, but it's an array, meaning it is gonna collect, it is gonna used as a collection of elements of the same data type, of integer data type in this case, right? So data type, this will be the syntax, data type, variable, and then open square brace and close square brace is the declaration. So this can also be written like this. So for example, integer a of open brace and close square brace, right? So this is the syntax of an array. How we declare an array? This is the declaration part. Now, how do we instantiate it? So there is something called instantiation after declaring the array. So till now we initialize the variable. we initialize the variable. What do we mean by that is we assign a value to a variable once it is declared. That's what we used to call it as initialization. And thereafter, whatever value we are going to assign to the variable, we call it as an assignment. Initialization is done at the beginning while declaring the variable. And after that, whatever value we assign to a variable is called as an assignment. Now, there's a new term called instantiation. What is that? Instantiation. So we declared the variable. This is not a normal variable. This is an array. Now we wanted to instantiate it. Meaning, so like this, we can do it in one step. New data type of, we have to say the size of it, like how many values I'm gonna store in this variable. Say for example, I wanted to store 100. So what will be the use case to store 100 of similar data type? Say for example, I wanted to store employee details. And so each employee will have one employee ID, right? So each employee might be having one employee ID. So in order to store 100 employee IDs, we need 100 variables usually without using arrays, right? But if if you use arrays, you don't need 100 variables. You can use one variable, declare it as an array, and then we can store 100 employee IDs in one variable. So as we know, say for example, we wanted to store 100 employee IDs, then we can declare the size of the array as 100. So this is the syntax of it. So how do we declare an array is declare variable and then open brace, close brace, close square brace. Example, this is the example. And what's the instantiation? So instantiation is we need to instantiate the array variable. What does we mean by that is? So this is the syntax of it. And let me give you an example. Int a equal to new int of. We can say like this. So which means what's the meaning of this is? So this is my array a, which is gonna be an array, meaning it is gonna actually store the integer values in it. It is array, so it can store more than one value in it, and it can store only integer values is what this means, the declaration part means. Then what is this instantiation? So if you clearly see this int integer, meaning so the new, this is a keyword, new is a keyword. So this says that, so we are asking JVM to reserve, hey JVM, this is an array and I'm gonna store 100 values into it. 100 integer values into it. I know that it could be like 100 values, or it can be even less than 100, right? So at max, I'm gonna store 100 values into my array. So please reserve me some space. So allocate some space on memory is what we are asking. So that is what this statement means. So new data type and then size. This is the syntax. So which means that we are instantiating an array. Instantiating array is allocating memory for the array, right? So in this case, it is allocating, JVM will allocate looking at this statement, new integer of 100. It knows that A is an array, right? As it is an array, it can store multiple values into it. But what's the size? What's the number of integer variables it is gonna hold is, that is what we specify here, size. So new integer 100, right? So in the same way, if data type changes, it will follow the syntax. We are just seeing an example as an integer, right? Now, let me show you how does actual array works, right? So say for example, earlier we can assign a equal to 100, that is fine. And also if you declare a variable, and if you wanted to store some value into it, we just assign it a equal to 100, right? Now, as it is an array, how do we assign? How do, we store the value into the array, right? And also, how do you read it? Read it is, earlier we used to store it, and then say for example, we wanted to print it on the console, we used to do system.out.println of a. Now, how do we even retrieve or read the value of array here? So two things, right? Storing value and fetching or reading that value from the array. So earlier variable it was simple. We used to use the variable which indicates that actual value, right? But no, it is an array. How do we, and also we are saying it is gonna hold multiple values into it. Now we need to know how we can store the values into an array and also how do we read the values back from the array. So let us understand that now. So it actually works this way. Say for example, this is an array. I wanted to store 5 values into it. Then how does it work? So this is how it will be stored. Say for example, I wanted to store values like this. 5 values into my array, right? My array size is 5 and I wanted to store 5 values into it. So this is how we actually store it. So what does we mean by this? So say for example, uh, each each one in an array is called an index. An index starts with 0. So for example, so index starts with 0 here. This we call it as index. So array is a collection of common elements, right? Of the same data type. And you can see if I have an array of size 5 and I wanted to store 5 values into it. So this is how it stores the values into it. So what do you mean by that is, so index starts with 0 usually. So it will be 0. First index will be 0. Whatever the value, first value in it is 0, 1, and so on, right? And how do we actually store the values into it is, so this is how we store it. Like say for example, a equal to a of 0 equal to 10, which means that a is a variable and in the first index, the first value of a is 10. So you need to remember the index actually, this is what we call it as an index, right? So using the index, we are going to store the value in an array. So if you observe a of 0, we call this as a of 0 equal to 10, meaning, so we said like in this integer array is a size of 5, right? So 5 uh, 5 integers size array will be declared and it will be instantiated. So we can store 5 values, 5 different values of 5 or same values of integers, right? So now this is how we store it. Now this is how it is allocated. But how do we store it? So this is how allocation is done. But how do we store it is a of 0 equal to 10. So which means that store a value of 10 in first index. So always remember index start with 0. It's not 1, it starts with 0 in Java, right? Array index starts with 0. So and then the next value, say for example, I wanted to store the next value. How do I store it? So a of 1, a of 1 equal to 20. So in the same way, a of 2 equal to 30. This is how we need to store the values into an array. So if you see, as the array is of size 5 and also index starts with 0, so it will end with 4. So say for example, if it was 10, array size was 10, then it will start with 0 and it will end with 9. So meaning, so an array, if it starts with 0, anyway, any array, it starts with 0. So it will end with, if there are n elements, it will end with n minus 1. So n minus 1. So in our case, n is 5. So it should end with 4. So the last index will be 4. So, and this is how we actually store the values into it. In the same way, so say for example, wherever I wanted to retrieve the value, say for example, I wanted to retrieve the value of second element. Second element is a of 1. It is not 2. So we need to remember index always starts with 0. So if I wanted to retrieve second element, I'll just say for example, I wanted to print this on the console, the value of this on the console. Then what do we do? System.out.println a of 1 is what we need to do. So that the second element will be read and it will be displayed on the console. So this is how we store the value into the array and also read the value into an array. And what happens, say for example, a of 4 is fine, right? Now say for example, I go beyond it and will try to assign some value a of 5 into it. Then what happens? So as the array is declared of 5 in our case, so but still you're trying to, insert a value into a sixth index. Then what happens? So so when we say sixth element, so a of 5, right? So when we are trying to store the next element beyond the size of array, then we get an exception. So it will throw an exception, array index out of bounds. This is an exception we are gonna get if we actually store the values beyond the store or read the value beyond the array size. We are going to get the exception, array index out of bounds exception, right? So this is how an array works, right? Now let us see an example on this array. So we do have two types of arrays. So even before that, like whatever we discussed now, let's summarize it. So array, what are the characteristics of array? Whatever we have learned till now, an array is a fixed size. So if you see this 100 is fixed or 5 in our case was fixed. If you go beyond and try to store this value, this will be, this will be invalid, right? So it is always a fixed size array. So you need to know approximately what will be the maximum number of elements you will be storing in your array. So it's always fixed size. It can't be changed. And if you go beyond and store it more value than the size of the array, we will get an exception called array index of bounds exception. So array is a fixed size. Once an array is created, its size cannot be changed. Change in the sense dynamically it can't be changed. Say for example, I declared it at once and I'm gonna store this values like this. Go on, store the values. So dynamically I can't increase the array size. But anyway, I can go to my instantiation and have it as modify the value later, right? But during the program execution, or if you are somewhere writing in the code, and if you wanted to grow your array size, it can't be grown. So again, you need to go back to the instantiation and change the value. That's the only possibility, right? So what do we mean by that is array is always a fixed size, and array is indexed. Array is indexed, meaning array elements are accessed using their index starting from 0. So this is important. So array elements are accessed using their index. So using only index, we can access the array elements. So element is nothing but one value into the which we are storing and reading from the array. So that's what we call it as array element. So index starts from 0. So there's a reason behind it, like why it starts from 0. So most of the traditional languages like C, so the index starts from 0 as C language supports pointers. And it's a memory offset, meaning it actually stores the value in contiguous memory locations. So in order to know what do we mean by that is, so say for example, we have, let's call this as a memory. So in memory, it's not stored like, the values are not stored like this. So say for example, 10 is stored here. 20 somewhere, like it's not stored like that actually. So it is stored in some contiguous locations. So this is memory. Say for example, it is not stored like this, 10, 20, somewhere 30, like that. So always it is contiguous. Contiguous in the sense, if you see here, So it stores in subsequent or in a consequent memory locations, so that it will be easy for JVM to access the elements, right? Clearly. So, and why do the index starts with 0 is, so it is implemented in such a way that if you say an index, say for example 3, which means that it is actually away from start. It is three elements away from the starting point is what it means, right? If it is 2, it says that it is 2 elements away from the starting position is what it says. So in this sense, if you see the first element, so the first element, if meaning it is one distance or one element away from the starting point, right? So if index starts with 1, it is not actually starting from, there is no other distance for it, right? So that is the reason index starts with 0. If it is 0, so which means that it is zero elements away from the starting positions, which is true, right? So if index starts with 1, so the meaning of the implementation will be ambiguous, right? So the meaning of index is it should be one distance from the starting position. Say for example, if it starts with 1, right? So it has to be one element, or the distance of the first element has to be 1 from the starting position, but it will be wrong, right? So it will be incorrect. So if it has to start with 0, because the initial point, it is no it doesn't have any distance from the starting point. It itself is the starting point, so it should be 0. So this is the reason behind index starting with 0. So fixed size, characteristics of array. Fixed size, it's an indexed one, so it stores only common element or elements of the same data type, which we call it as homogeneous. So all elements in the array must be of the same data type or of same data type. And also they are stored in contiguous memory locations. So this allows for the efficient access to the elements. So because using the indices, we can access any element very fast, right? Say for example, there are 100 elements and you wanted to read the 50th element. You can just say A of 50. So whatever element is stored, 50 is not a value. A of 50 is, an array where 50th element is, or, uh, 51st element is stored, right? So in order to access the 50th element, we need to have A of 49, which actually retrieves the 50th element in an array of 100 size, right? So this is how we actually store and retrieve the values. So stored in contiguous memory locations means, so it is stored in continuous memory locations in a consecutive manner. Like it is not stored random, but it is stored in a consecutive memory locations. That is what we call it as a contiguous memory locations. So which allows for the efficient access, as these are stored contiguous, so it can be easily retrieved using the indices. So these are all about the characteristics of arrays. Now we will see what are the types of arrays we have. So we have two types of arrays. So one is single dimensional array. Second one is multi-dimensional array, or we can call it as double dimensional array. Single dimensional and multi-dimensional array. And in that multi-dimensional, we are going to discuss about two-dimensional in today's session, right? First, let us see what single dimensional array is. What is single dimensional array? So single dimensional array is whatever we discussed now, right? So so it will be having an array, like it's a collection of elements of the same data type, and we can store it and we can read the values from it, right? So we'll see by taking an example. So these are the different operations. So in a single dimensional array, we can perform. So it can store, multiple values into one variable index is the key here. Like using the index, we actually can store the values and also read the values. So let's see an example now and understand. So say for example, this is single dimensional array and we are gonna understand the characteristics. So how single dimensional array works. These are the different operations we can perform on single dimensional array. So let's take an example and understand. I'm going to create a new package for today. I'll call this as basics. Create a new class, single dimensional array. All right. So let's start with declaration. So how do we declare an array? We will learn how do we declare an array? Say for example, integer, right? Int a equal to, I wanted to store 5 values into it. I know I'm gonna store 5 values into it, into my array. So then we declare it something like this in new int of 5, meaning so it a is a variable or a is an array of size 5. That's how we need to read it. Meaning A is an array which is gonna store 5 integer values into it. And this is what instantiation is, declare, and also this in the same place we are instantiating it. Declaration and instantiation of an array, right? So this is the syntax of it. So 5, so a memory has been allocated to store 5 elements into the array called A. No, that's the meaning of that statement. Now we wanted to store values into array. So how do we store the values into an array? So we wanted to perform all these steps now in single dimensional array. Store values into an array. How do we store? We have seen. So here is an example, right? We can see here, say for example, in the first element or in the first index, I wanted to store 10. So this is how we can store it. This is how we can store the elements in an array. A of, so this we need to read it like this. A of 0. So as this is in square braces, A of 0, meaning first element in an array. And then you can initialize and value to it. A of 1. You can initialize the value here like this. So on, you can initialize the values to an array. So this is how, meaning we store the values into an array. Now, how do, so in this is one way of storing the values into an array. Now we can declare an array and also, initialize the values to an array at one go in one, in one statement. So how do we do that? This is method 2. First one was method 1. So declaring and also instantiating an array at one place, right? So now without instantiating also, we can actually store the values. So how do we do that? And also remember, we can even declare an array something like this. We don't, the square braces can be even before the array declaration. So even this is the valid syntax. So earlier, or say, so we have like this, right? So these square braces can even be before the variable name as well. So both are valid. If you see, there is no error, right? So just remember that. And now declaring and this is one way of declaring and instantiating an array, right? So we are seeing the method 2. So in this method, we don't need to instantiate the array. we can just store the values directly without declaring the array size. Say for example, this is the method. So meaning directly A is an array and it is saying this is already exists. So A is an array and it is storing these values. So here we don't need to specify the size of the array. So as we are actually assigning some values into it. So which means that we are initializing the array. It knows there are how many elements in it. So based on that, it allocates the memory and stores it in the array called A, right? So at this place, we don't need instantiation as we already initializing the values to the array here itself while declaring the array. So this is another method. So when we know in advance, like what's the value of, okay, it is saying it's already existed. So let's call this as some B, right? Now, if you see, if you know that if you have a fixed size array, what's the size of an array, then you can go with the method one. Or if you do not know the size of your array, so you can actually, but if you know the values, then you can use the method two. So this is how we declare and instantiate an array. Now, let us find the size of an array. So how to find the size of an array? We wanted to find the size of the array. So we can find the size of the array using a dot length. So say for example, variable dot length. So this actually returns an integer value, meaning the size of the array. Size of the array is what will be the maximum number of elements the array can hold, is what the length property will give us, right? So A is an array here in this case. So array dot length actually gives us the size of the array. So what is the size? Size is the maximum number of elements a array can hold. So how can we know that? So while declaring, we know like whatever the number we are giving here to allocate memory, right? So that will be the number, that will be the value for the array length. So length is a property, it's not a method. So we have to use it as a dot length. Now let us see and print it in the console. What's the length of the array A? So we can see clearly the array size is 5. Array size is 5 here. All right. So this is how you can actually find the size of an array. So we use the length property of array. Now we wanted to read single value into an array from an array, right? So how do we read the single value from an array? We have already seen. How do we store it? Store the value in the same way we read the value. Say for example, I wanted to display or read the first value from an array, first element from the array. So this is first element in the cell which starts with index 0. So A of 0. So we can see the first element, it has the value 10. Actually, we didn't comment this length. So you can see the first value stored is 10. In the same way, say for example, I wanted to retrieve the fourth element. Then I would provide the value as index 3, A of 3. A of 3 is 40 in this case, and it actually displays the value 40, right? So this is how we can retrieve the single value from the array. And say, for example, I wanted to retrieve last value. I'll just say A of 4. You can see 50, right? 10 and 50, first value and last value. Now, say, for example, I will retrieve some value which is not even there. A of 5 is not there, right? It actually ends with 4 because the array size is 5. The index starts with 0. The index starts with 0. So it will end with n minus 1, meaning the index ends with 4. But what I'm trying to do, I'm trying to read the value A of 5, which is not valid for this array. So if you see, we get an exception. It says array index out of bounds exception. So we should always remember we should not go beyond the array size. And we because we can't store beyond the index size, we can't store elements into the array, and also we can't retrieve the value from the array. So this will be invalid in this case. So when we declare it as 5, we don't need to store all the elements. Like say, for example, if I have 10, I can declare 10, but I might be actually having the values only 5. That is valid. But the reverse of it is not possible. If I declare the size of 5, I can't store more than 5 elements into the array. So we have to remember that. Now we have seen how to read a single value from an array. It's simple. Using the array name, and then index. So index is the key for the array, right? So what's the index you wanted to read the array from? So that's what we need to specify. So a of 0 retrieves the first element. And whatever the index you wanted to have here, you just replace this index here. Then the value which is stored at that particular index in the array will be read or retrieved from the array. Now let us see how to read multiple values from an array. Now I wanted to read multiple values from the array. So single value, it's simple, right? So we can just have something like this or something like this, which is valid, right? So we know it will actually display this value, which is stored at this index, right? Now I wanted to store or I wanted to read all values or multiple values from the array. So we can do it something like this, right? System, we can just modify the index like this. So these are the three values. But say, for example, I wanted to display 100 values in one go. Then I need to have 100 statements like this, right? So instead of that, if you remember in the last session, if we are repeating the same statement, what can we do? We can loop it. We can use the loops. So that's what the concept of loops is, right? So if you wanted to repeat the same statement or same line, if you have same line or same block of code, if you wanted to repeat multiple times, we can loop through it, and you'll just wherever something is varying, so that we'll actually have it as a variable, and then we'll write the logic for that, right? So here in this case, what we can do, so what's varying? It's clearly see, you can clearly see that the only place it's varying is index. So for index, we can actually have a variable, as that's the uh, only thing varying, right? So we can have it as an index. So index equal to, I'm gonna use for loop here. So if you remember, we initialize the for loop first. So I'm gonna start with 0 because index starts with 0. Then index less than, so this is important. So index plus plus, every time index has to be incremented. This is fine. Now, but what will be the condition? It has to actually stop till after the size, array size. So how do you know the size? So say for example, in our case, we know it is 5, right? So index less than 5. So if you remember, if you see here, the condition index less than 5, meaning, so first it displays a of 0, fine. Next it goes and, increments the index value. And then checks the condition. It will be 1, no. 1 less than 5 is true. A of 1, whatever the value in 1, it is 20, right? So it will display the value 20 and so on. Once it displays the last element 50, the index will be 4, right? 4 less than 5 will also be true. So A of 4 will be displayed. But once after that index increments, then the value of index will be 5. Now what should happen? So index is 5. 5 less than 5 is false. So it will come out of the loop, right? So let us see that in action. So you can clearly see that all the values have been displayed, right? We can to know more, like we can even debug this and how it is working, right? So how to toggle the breakpoint? You just need to place the at the start of the line. You just need to double click on it. So a small blue bubble will be displayed. So that's what we call it as toggling the breakpoint. And then instead of running, we use run as we use debug as. We wanted to see the flow of control, how the control flows through this execution, right? So it actually stopped here because we set a breakpoint here. We have toggled the breakpoint. So the execution actually halted here. Now we will press F6, function F6 key. So if you see here, once I press F6, so you can see the value of index here. So it is 0, right? It is 0. It is 0 here. Index is 0. And it verified the condition 0 less than 5, yes, true. So it has to display the value. It entered into the loop and it executes the statement within the loop. So the statement within the loop is a of index to print the value of a of index on the console. So it displays the value of a of 10. Now it has to increment the index value by 1. So if you see, it will increase it. So if you see, index has changed to 1 here, clearly. You can also hover or on this variable and look for the latest value of the index. So this variable index has the value of 1 in the current iteration, right? So it has to display next value. It enters into the loop because 1 less than 5 condition is true. So it will display 20, right? In the same way, 3, a of 4, sorry, a of 3, right? And then a of 4. Index is 4 now. Now, 4 is incremented to 5 now in this iteration. So 5 less than 5 will be false. So it has to exit the loop. It will exit the loop clearly. See, it exits the loop because index is 5 now. And this condition has become false. So this is how, we can read multiple values from an array. So there are, again, like while writing this condition, you have to be careful. It can be less than 5 or so index starts with 0 and index starts with 4, right? In this case. So how can we write less than 5, or if you are comfortable with like this writing, as we know, it starts with 0 and ends with 4. So you can even write it something like this, less than or equal to 4. So the condition will stop once the index value is 4. It will not go beyond that because the condition will become false. So you can write it as less than or equal to 4 or less than 5. Both are same. You can write, you can use any condition. So it is very much equivalent to index equal to 4. Both are same. So let's see for 4 like this. You can see the same output here because this is also the same number of iterations. It starts with 0 and every time it increments and it will actually iterate through the loop 5 times because it starts with 0 and it till the index is 4, meaning 0, 1, 2, 3, 4. So it will iterate through 5 times through the loop. So we have to be careful while writing this condition. So it has to be either 4 or 5 and it has to be less than or equal to or less than. So if we are trying to use the last index, then it has to be equal, right? If you are going to use the size 5, then it has to be less than because it is not starting with 1. Index starts with 0. So it should always be less than, you know, one the size of the array, right? So according to this, say for example, I can have n number of elements into an array, right? So as we know the size already, we know the size 5. So we are having hard-coded 5 here. So the good practice here is we don't know what the size of array could be, right? In all the times. So how can we actually iterate through? What can be our condition here is, so what is 5 here? Length, size of the array, right? So how do we get the size of an array? We just now learned using the length attribute or length property, right? So a dot length is what we can use it here as a condition. So anyway, a dot length, the value of a dot length is 5, right? So this value will be replaced with 5. So index less than 5. That will be the condition. And we can see the same output here, right? So instead of hard coding the value 5, it could be 100, it could be 500, any number, right? So instead of writing the number and changing the number in the condition for the index, we can use the length of the array. We can use the length of the array, and we have to be careful, like writing the length of the array. So a dot length is 5, but the index actually starts with 0 and ends with length minus 1. So this is what we have seen, right? It starts with 0 and it ends with n minus 1 if you have n elements into it. So we are writing less than. But if you wanted to write less than or equal to, then it will be definitely minus 1, length minus 1. So you can just imagine the length in this example as 5, right? So if you wanted to use equals to 5 minus 1, so less than or equal to 4, because 4 will be the last index as the index starts with 0. Or say, for example, I wanted to use only a dot length, then it has to be less than length. It should not be equal to length, right? So we have seen this. I think I already executed this, and you can see the output. Say, for example, by mistake, if you say less than or equal to a dot length, so you are going beyond the array index and trying to retrieve the value in it. So you'll anyway, first 5 elements will be displayed. But when you try to actually go beyond the array index, then you will get an exception called array index of bound exception. So you have to be careful while writing this condition. A less than a dot length, or if you wanted to use equals to, it will be 1 less than the size of the array. Both are same. Both are valid. So this is how an array, single dimensional array works. Is that clear? Is it clear, everyone? So if it is clear, we can actually jump on to the next topic. All right, so let's jump on to the next topic then. So next topic is two-dimensional array. Yeah, before jumping on to the two-dimensional array, so we will also learn about enhanced for loop here. So this is how we have written this is a traditional for loop, right? We know it will initialize the value, we write a condition, and we will use increment or decrement. Now, if you remember in the last session, we just we just came to know that there is another loop called enhanced for loop, but we have not seen it. Enhanced for loop, or it is also called as for each loop. For each loop, right? So how does that work? Let me show you the syntax of it. So data type, data type, and an element data type, a variable, and then the array here. So this is the syntax of the enhanced for loop. So you'll understand it with an example. Say, for example, in our use case, in current use case, what's the array? Array name A, right? And if you observe, this is colon. So it will deviate from the traditional for loop. So you should not compare it with the traditional for loop. So it will be different. I'll come to that point. Now, according to the syntax of enhanced loop? So from the array, you can have the variable here. So say, for example, I'll say element, and then you can print the element. So this is one other way of displaying or retrieving, reading values, all the values from an array. Right? So you can see it actually displays all the elements from the array. But how does it does this? So it is actually, this is enhanced for loop, meaning it will not be same as the traditional for loop. You can see here, right? The syntax of it changed completely. And you see, this is not semicolon. You have to be careful. This is colon. So the meaning of this is there is an array. Fine. From that, read one by one element, and you can use that element in your code, in your block of code. Once it enters into your loop, then you can actually use this element in your loop, in your block of code, right? So what does this mean is for each element of A is what it means. So you can't actually have the indices here. You can't actually access the element using the index. It will be in sequential. So we know, right? So the array, how is it stored? So it will be like this, right? And it will be in sequence. So whatever the values are in sequence, so it will actually, you know, display like that. 10, right? 20, like that. So it will actually display all the values here in sequence, right? It will not actually follow those, it will follow from 0th index to the last index. So you can't actually control using the indices using the enhanced for loop. So this is very simple. The meaning of this is from the array A, read all the elements starting from 0 till the last index is what this means. That's what the enhanced for loop is. And for the syntax is simple. First, you will have A, and beside that, onto the left, you will have colon and element, meaning the array value of each element. Say, for example, you know this one element from A. First element from A will be read, right? From this element first element of A will be read, and it will enter into the loop. So you can use that first element, whatever you wanted to do that. In our case, we are just displaying on the console, but you could do anything with the first element. Then it goes back to the loop again. Then it will read the second element. We are not specifying the indices. We are not doing anything, but that's the internal implementation of enhanced loop, and that's how the enhanced for loop works. So the second element will be read, and the second element will be, it can be used inside the loop. There will be no condition here. No, then it will go back. It will use next one. Next one will be 10, 20, right? Next will be 30. And in the same way, again, it goes back. So it will use the next element, that is 40, like that. So we are, say for example, we have something like this. It will display all the elements in the array. So once it displays the last element 50 from array, then it will exit the loop. So this is how an enhanced for loop works. So for each element of the array, so it will actually enter into the loop once, and it does it in sequence. It is not random. So first element, second element, third element, like that till the last element. So each element or the value from the array will be read according to the index sequence, and will enter into the loop until the last element. Until the last element will not have control over it. You can't randomly access the particular index from the array. So you can't do that using the enhanced for loop. So if you wanted to do that, you can go for the traditional for loop. So this is an enhanced for loop to iterate over all elements. So we should be using this only when you wanted to iterate over all the elements, right? So let's see the advantages of the enhanced for loop. So what are the advantages of the enhanced for loop is its simplicity. So the enhanced for loop is easier to write and understand, right? So it's very simple to use. It's simplicity, and it is safety. It helps you avoid common errors like, half by one errors, and also incorrect index usage. Incorrect index usage in the sense like, we have seen that, right? So you might not be knowing like whether I have to use a dot length or a dot length minus one, like that, right? So you don't need to worry about that using the enhanced for loop. So it is safety to use. It avoids common errors. So we can say it is safe, and it is also readable. So it is very much easy to read your code, right? So the code clearly says that you wanted to iterate over all the elements. So we can say readability as well as an advantage of enhanced for loop. And when to use. So when to use for loop, when to use enhanced for loop is when you wanted to iterate over, or when you wanted to iterate over all the elements. So we call that as traversing all the elements. So when you need to traverse all the elements, we can simply use the enhanced for loop. And when not to use the for loop. So when you should not be using this for loop, when you wanted to modify the elements. So when you wanted to modify the elements, we should not be using the enhanced for loop, because you can't actually have you don't have the control over the indices. You can't actually access the element at the particular index using the enhanced for loop. So you can't actually modify the elements. As you can't modify the elements, you should not be using enhanced for loop when you wanted to modify the elements. And say, for example, you wanted to access the indices for some reason. As enhanced for loop doesn't deal with indexes, or you don't have the control over indices, you should not be using uh, enhanced for loop for accessing the indices. And if you have some complex logic, say for example, if you have some complex iteration logic, like if you wanted to skip the elements using continue statement, or if you want to iterate in reverse, say for example from last element to first element, or if you wanted to remove some elements from the collection, then you can't use this enhanced for loop. Then you need to go for the traditional for loop. So because iteration using the traditional for loop will be more suitable for all such type of complex logics. So to keep it simple, in summary, when can we use the enhanced for loop is when you wanted to traverse all the elements. Only then we'll use the enhanced for loop. For all the other cases, you can go for the using the traditional for loop. So this is all about the enhanced for loop. Any questions? Is that clear? You can put your response on the chat. All right. So now let's go to two-dimensional array. So we call this as multi-dimensional, and here we'll see two-dimensional array. This is also called as double-dimensional array. So how does two-dimensional array works? Let's see that now. Now till now we have seen how to store values into a single dimensional array. It is straightforward, right? So we can store the values and read the values using the indices. Now we wanted to see two-dimensional array. How does two-dimensional array works? Let's see that now. So unlike single dimension, we'll be having two dimensions now. So we'll be having two dimensions in the sense. So say for example, it will be something like this. Say for example, I have 3 rows and 2 columns. So it works this way. So first, let me show you the syntax of it. So then it will be easy for us to compare it with the single dimensional array. As we already are comfortable now with the single dimensional array. So let's first see the declaration part. So earlier we used to do like this, right? Single dimensional array, A of square brackets, right? Now, how do we declare two-dimensional array is two times. So the square braces, we'll have it two times because to represent that it's a two-dimensional array. New int of, I'm just going with int for now, but you can actually have it any data type. Now this is the declaration part. So declaration part. So usually for a single dimensional array, we use square brackets like this, but we use two times square brackets just to indicate that it's a two-dimensional array. So how do we actually instantiate it? Instantiating it is allocating memory for that two-dimensional array, right? A of 2. Say for meaning, so this is first indicates number of rows, second indicates number of columns. So don't worry on that. I'm going to explain it now. So 3 is rows, 2 is columns, right? So this is how you instantiate it. And the declaration could be like, even this works. So you can have both both the square brackets before A. So this is also same. This is also same as the first one. We can even use it like this. Or we can even have one square bracket before the array name and one after the array name. Like this also. All are valid. Right? And coming to this point, new, we need to allocate the memory for this. What is 3 and what is 2? That we are going to see now. The first number indicates row. So it is row. This is column. This is the example of it, right? So in our example here, there are 3 rows and 2 columns. Let's take that as an example and understand what we mean by two-dimensional array, right? So in our example, we have 3 rows. So what do we mean by 3 rows? Yes. So this is the row. So we read row from top to bottom. So that's what we mean by a row. Okay. So this is a row. Row will be read from top to bottom. I'll call this. This is row. And column is reading it from left to right. I'll come to this. We call this as column. And we call this as row. These are 3 rows. So you see 1, 2, 3, 1, 2, 3. And again, row and column also starts with the index 0. So how do we divide the columns? So we can divide the columns like this. This is first column. This will be my second column. And again, indices. So it again starts with 0. It is 0. 0th index, first row. So here, as we read from top to bottom, we need to call this as rows. So 0th row, first row, second row, right? Columns. So how do we read the columns? So 0th column and the first column, right? Columns are always read from left to right and rows from top to bottom. So this is what we call it as row by column. So row by column, and you see this is a 3 by 2 matrix. So meaning when you see 3 by 2 matrix, 3 by 2. So the first one, we should always consider it as rows. Second represents the column. So when we say 3 by 2, so we can store 6 elements into it. And how we can store it, how we divide that is using 3 rows and 2 columns. So 3 rows in the sense like each row starts with the index 0, 0, 1, 2, and columns also starts with the index 0, 0, and 1, right? So when we say one row and one column, say for example, let's see how to store the values, then you will get it. So A of 0 is my row. The first index always indicates the row, and A of 0 again, meaning first row, first column. Store a value called 10 is what we are saying. Then 10 will be stored where? Here. You see clearly, 0th row, 0th column. This is the place where we store the value 10, right? Value 10 will be stored here. So now if I wanted to store values, other values. So I wanted to store A of, say for example, at this position, A of 0, 1. Say for same row, first column I wanted to store. Then we can store it something like this. A of 0, 1 equal to 20. Then here 20 will be stored. Now it is simple. You can have a table like this, matrix like this, then you will clearly understand, right? A of 1. So the row is done now. So our row has only 2 columns. We stored 2 values into it. Now we need to go to the second row. Second row is start with index 1, right? A of 1. Now we are in the second row. Fine. Which column I wanted to access? I wanted to access first column. Then it will be 0. A of 1 will be the first row. I wanted to access column with index 1. Now, second row is also done. Now we need to go to the third row. A of 2 of 0, 50, right? So here 30 will be stored. This is 1, 0. A of 1, 0. A of 1, 1. A of 2, 2, 0. Right? A of 2, 0 is 50. And A of 2, 1 is, let's store it as 60. So how do we write that is A of 2, 1. So always the first number indicates the row. Row is here, you can see. Column is from left to right. Row is from top to bottom, right? So index, again, row index also starts with 0, column index also starts with 0. We have to be careful in the indexes. So this is how we store the two-dimensional array values into the array. So this we call it as we have 3 rows and 2 columns, we call it as 3 by 2 matrix. 3 by 2 table, anything, right? 3 by 2 array in that case. So always the first number indicates row, second number indicates column. So this is about two-dimensional array. So a basic understanding of two-dimensional array and how the elements are stored in the array, right? Now we'll see how to store values. Like this is how we store the values, right? And in the same way we read the values. Say for example, I wanted to read first row, first column, right? So in that sense, first row, first column is as the index starts with 0, 0 of 0. And then I want to access second row, second column, then it will be 1, 1. Second row, first column will be 1 of 0. A of 1 of 0 will be the second row, first column, like that. So always when we say, when we wanted to access second row, then it will be just 1 less than, index will be just 1 less than the row number, and column also same. If you wanted to access first column, then it will be 1 less than the column number you wanted to access. Like first column in the sense, the index will be 0. If you wanted to access the second column, then the index will be 1, like that, right? So as the index starts with 0, the last index will be n minus 1. So this we need to remember. Now let us understand two-dimensional array with an example. For that, I'll be taking, okay, just close the debug perspective. Now let's create a new class. I'll call my class as two-dimensional array. So first declare, right? Declare a two-dimensional array. How do we declare it? Int, like this. I can store a row number here and column number here. So I have to specify the size using the row and column, right? So in our example, let's take 3 rows and 2 columns. So row can be any number and column could be any number. It need not be equal. It can be any number, right? Based on that, an array will be created. So this is how we declare an array, right? So let's see now how to actually store the value. So how to store the values into it? Store the values in the sense we have written here, right? So how to store the values? It's a two-dimensional array and we have rows and columns. So in order to access first row, we use the index as 0. A of 0 is itself is a first row. Now, within the first row, I wanted to access first column. Then I will specify 0. Within the first row, if I wanted to access second column, then we'll mention the index as 1. It's so simple. So this is how we actually store the values. See, 0 of 0, right? 10. 0 of 1. If you wanted to store 20. 1 of 0, meaning first row, first, second row, first column. Same second row, second column. Now, third row, we are in third row. So even though we are third row, we specify with the index 2 and the first column. Third row, second column. Second column in the sense index 1, right? This is how we store the values into a two-dimensional array. And again, this is method 1. How do we declare, instantiate, and storing the values? So there is another method. You don't need to instantiate it, but you can actually declare and assign the values into it. So this time, let's actually declare it like this. But both are same. So how do we initialize the values into a two-dimensional array? So earlier, we used to do something like this, right? As it was single-dimensional array, we used to initialize the element values to the array like that. But now it's a two-dimensional array. So two-dimensional array will be something like this. So within the array, it will be an array, right? So 10, 20, 30, 40, meaning this is my first row in row. And in that, the elements are 10, 20. Then that we have to enclose in the braces. So which indicates that it's a row. So outer braces, we already have it. So if you observe, so these are the braces, we already have it. Just like the single dimensional array. But within the single dimensional array, we do have the rows and columns, right? So to indicate the row, again row can have a number of columns, right? So just to indicate that it's a row, the first row, we again need to have the square braces, braces, right? Curly braces. So 10, 20. Within this first row, I have two values, 10, 20. Then comma indicates my first row is done. I'm done with the first row, right? What will be the, I'm starting my second row. So the second row, I can have again, a number of columns. So I'm having 30 and 40 as my column values, right? So this is how you can initialize the values to a two-dimensional array, right? First row, two columns, 10, 20. Second row, 30, 40. This is how it will read 50, 60. Third row elements are 50, 60. And how each one is read, first column and second column. So this is how we can initialize the two-dimensional array. So we are not instantiating here, meaning we are not specifying the size of it, but directly initializing the values to it. So it is very much similar to this approach. This is method 1. How to store the values into two-dimensional array. This is method 2, where we declare and also we will initialize the values to the two-dimensional array. And just put it something like this. Or if you are getting confused putting this like this, then you can arrange it some like this. Say for example, this is my first row, right? This is the second row. This is third row. Now it will be much comfortable for readability, right? So 10, 20, meaning first row, first column, second column, second row, third row elements like that. So this is how we need to understand, and this is how we can store the values into a two-dimensional array. So let's actually perform all the whatever operations we perform for single dimensional. Let's also do it for the two dimensional as well. So we declared array. We saw how to store the values into array. Now we'll see how to find the size of the array. So how to find the size of the array? It was simple to find the size of the array using the you know in single dimension. You use the length attribute, right? So how do we do that in two dimensional array? So the same, like we are going to use the length attribute again. How do we find the size of a two-dimensional array? A is the array, right? So usually we use a dot length, right? So in here, in this case, if you say a dot length, so the first value will be row always. This is what we have seen, right? So if you say a dot length for this two-dimensional array, it is gonna return only rows. It is gonna return only rows. So it will say number of rows. So number of rows here is 3, right? So we can even see that. So it will just say number of rows. But two-dimensional array is not about single number. So whenever we say two-dimensional, it is of two numbers. We always need to speak about rows as well as columns. Rows and columns, right? But if you see a dot length here, it is only returning number of rows. But how about the columns? We wanted to read the columns as well, right? So how do we know the size of the column? So how do we know it is a of, you can provide any number here, any row for which you wanted to find the number of columns, right? So you see if each row has equal number of columns, then you can specify any row here, any row number, a of 0, right? A of 0 indicates first row. It is actually indicating the first row, right? Now it says a of 0 dot length, meaning it will now actually display the columns. So it will actually display the number of columns. You can see it displays 2, right? So these are the number of rows. These are the number of columns. So a dot length, a is an array of two-dimensional array. A dot length actually gives you the number of rows. But if you wanted to find the number of columns, then we take one row first. So you can take any row, and so I am in the first row now. So a of 0, point into first row, then first row length. So you already know it's a row. A of 0 indicates row. So it will not actually provide you the information about the row. Instead, number of rows. Instead, it will actually provide you the information about the number of columns in it. A of 0 dot length, meaning it will provide you the number of columns within that particular row. But on the array itself, if you actually try to get the length, it will actually provide you the number of rows. So this is how you need to find the size of the two-dimensional array. So simple. Earlier in single dimensional array, when we wanted length, we use dot length, right? So in the same way, if you use the length property here, you will get only number of rows. In order to get the number of columns, we need to specify the row number, a of 0. We need to point to some row and then try to find the length. So as it is already pointing to the row, it will provide you the number of columns of that row. In our case, all the rows have same number of columns. So we can use any index here. Say, for example, I will use 1, right? So it will actually display the number of columns as 2 again. The number of columns is 2. Number of rows is 3. So you can point out to any row. You'll get the number of columns as 2. Because we have declared it like that, right? 3, 2. So 3 rows, 2 columns. Our array itself is like that. So 3 rows and 2 columns. So in order to get the number of rows, we use the length property directly on the array. And in order to get the column count or column size, then we will actually specify the row and then use the length property on top of that row. So this is how we get the size of the two-dimensional array. Now let us see how to read a single value from the two-dimensional array. A of 0 of 0. That's it. It actually displays the first row. First row, first column. See 10. First row, first column is 10, right? Then if I wanted to display first row, second column, it will be 20 and so on, right? So if you change the row number and column number, so according to this matrix, you will get the values because that is how we have stored the values here. So I'll just comment this out. We'll use this EA array. So if you see all these values here, or you can use, if you are comfortable with B, we'll use B itself. Right? So B0 of 0, it will be 10. 0 of 1 is 20. You can see this is how the values have been stored, right? So in the same way, we can read any value, any row, any column, right? You just need to modify the indexes. According to that, the value can be read from the two-dimensional array. So this is how we can read the single values. And how do we actually read the multiple values from the array? So how to actually read the multiple values from the array? We'll see now. Reading single value is simple. We know, right? You just need to provide index, right? Index of row, index of column. Now, how do we actually read the multiple values from the array? This will be interesting. So here, we wanted to read row and also column. So how do we do that? So first, what we'll do is we'll loop through a for. We'll write a for loop to actually loop through the rows. So how many rows we have? We have 3 rows, if you see, right? So we can loop through 3 rows. So we can write a for loop just for rows. What will be our condition? It's simple. Rows are less than or equal to 2, right? Or you can say less than 3. So let me put it here. A for loop, right? This will be a for loop and row will be less than 3. This will be my condition, right? It is simple. And row can start with 0 as the index starts with 0, right? And it will be row plus plus, meaning we wanted to iterate through all the rows. In order to iterate through all the rows, then what we can do is we can actually iterate over all the rows like this. It is simple. So now, how do we retrieve the columns? So row is fine. So with this, what happens? We can iterate through each row. 0th row, first row, second row is fine, right? It will point to the rows. But how do we access the columns within the row? So this is how we access the columns. Within the for loop, we write another for loop saying that, so I wanted to read all the columns. So in this case, 2 columns, and it has to start with 0. And every time column has to be incremented. So with this, what we are saying is this loop. So if you see, what does this mean is, let me bring it here. With this, what it means is, so we are saying first row. Say for example, we wanted to iterate over all the rows. So then we call this as an outer loop. So this outer loop, what it does is, so it actually iterates over all the rows. First row. So this is the first row, right? It points to the first row. Row less than 3, yes, true, right? So it will enter into the inner loop. This we call it as inner loop. This is outer loop, and inside we are writing another for loop. This we call it as inner loop. So if we have one for loop inside another for loop, we call it that as nested for loop. Now, why are we doing this? Once we wanted to read all the elements of two-dimensional array, so we iterate over rows. Rows will be the first number, right? So once we enter into the row, we wanted to read the column for each row. So for the first time, we'll have the 0, right? 0th row. Say for example, first row, 0th row. We enter into the loop if this condition is true. Obviously, this condition is true for the first row. Now we enter into the loop and then observe carefully. So the column, right? So column is 0, column less than 2. Yes, for the first time, even this condition will be true. So we entered into the loop, and once we entered into the loop, we again saw another for loop. So according to that for loop, so the initialization happens column equal to 0 and 0 less than 2 will be true. Now we will say A of my row. Row number is fixed. It is 0 and column number. Column number is, for the first time, it will be 0 and row is anyway fixed. It was fixed, right? 0. For the first time, we entered into the loop and it was 0. And column is now 0 for the first time. So for the first time, it will be A of 0, 0. Then what happens? The inner for loop is end, right? So we wanted to display only, say for example, we wanted to display only this value inside the for loop, inside the column for loop or inner for loop. Now the loop has ended. Now we go back to this. So as this loop ends, so it will go back here and it will actually increment the column value. Observe carefully, column value, only column value, right? So column value, then 0 will be 1 now. 1 less than 2, the condition will be verified as this is a traditional loop. 1 less than 2, true. Now A of row comma column, A of row of column. Row is still 0. We are in the inner loop now, right? So with 0 as the row number. Column is 1 now changed. So A of 1. So A of 1 is 20. So 20 will be displayed. Next, it will go back and column will be incremented. So column is value is 2 now. Is 2 less than 2? False. So it is false now. So it will come out of the inner loop. So it is out of inner loop and it has to go back to the next line of code. There are no more statements. If there are no more statements, then it will go back to the outer for loop, this for loop, and it increments the row value now. It was till now the row was 0 as the for loop, the inner for loop has completed. Now it has to execute any statements if there are after the inner for loop. So if there are any, it will execute all those statements and then it will go back to the next iteration for the row. So next iteration for the row will be row plus plus. Row was 0 till now, it will be 1 now. 1 less than 3 will be true. Again, it will enter into the loop. Again, the inner loop starts. Again, the inner loop starts. Inner loop starts for the column. Again, the same story. Like this time, instead of 0, row will be 1. And then column will again start with 0. Column less than 2, 0 less than 2, true. So column 0 will be displayed, 1, 0. So this value will be displayed, 30. Next, column plus plus, right? So as the loop ends, inner loop ends, it will go and pick the next index, next column, right? So next column will be column plus plus. It will be 1. 1 less than 2, true will be true. And it will, row will be anyway 1, right? We entered with the 1 into this inner loop. So A of 1, 1 will be displayed. Again, column 2. So 2 less than 2 will be false. So inner loop will break and it will actually go to the outer loop. So this time row plus plus. Row will be 2 now. 2 less than 3. Yes, true. It will again enter into the loop. Now again the inner loop. It will start with column 0. So row will be fixed. For this iteration, row will be 2 and column will be, it starts with 0. So first time it will display 2 of 0. It will be 50. Then column will be incremented. So column index will be 1. 1 less than 2, true. So row is anyway 2 fixed. Column is now 1. So 2 of 1. So it will display 60. Then column will be 2. 2 less than 2, false. Right? It will break the inner loop. Now observe. It will go back to the row. Row was 3 till now, fixed, right? Now it will be 3. 3 less than 3, condition will be false. It will come out of the outer loop as well and will, print the or execute the block of code, whatever has been written after the outer for loop. So this is how it works. So this is what we call it as a nested for loop. So if you observe, we didn't have one for loop here. We had a for loop, but inside it till now we have seen one for loop, how it works, right? Now we used for loop within for loop, another for loop. So this is what we call it as a nested for loop. So let us see this now. So let's write code for this. Where int row equal to 0, row less than 3. As I have 3 rows, I wanted to iterate through all the rows. Now, for each row, I wanted to start from first column and iterate through all the columns. So this is the nested for loop. And what we wanted to do for each column also, we wanted to display elements like this: A of row of column. So let us see the output. So we can clearly see, yeah, we are also getting this one. So let's comment this out. So you can see number of rows, number of columns is fine. And you can see, let's execute this. And now we can see all the values have been displayed from the two-dimensional array: 10, 20, 30, 40, 50, right? So this is because how did it work? So for the first row, we have written two for loops. So outer for loop, this we call it as outer for loop. This we call it as inner for loop, right? So outer for loop, this will be outer loop. This will be the inner loop, right? Outer loop and inner loop. So A of row of column. This is what we wanted to display, right? For the first time, when we enter into the outer loop, row value will be 0. So as this condition is true, we enter into the loop. Fine. Now, as the loop itself has a statement which is for loop. So we have to start with the inner for loop again. So what's the value of it? Column equal to 0, right? So it starts with this for loop with column as 0, column value as 0, right? And this condition is true. So it enters into the loop. So we have to remember the indices. It started with row 0. So 0, column is also 0 for the first time. So it displayed the first value. So let's debug and verify. I'll toggle the breakpoint here and then debug as Java application. Now see. So for the first time, so let's also see the indexes here. So for the first time, row is 0. It entered into the loop. It also entered into the inner loop. And you can see row is 0, column is 0. It has to display A of 0, 0 now. A of 0, 0 is 10. Yeah, it displays 10. Right? Now, it goes back to the inner for loop because there are no more statements to execute after this statement. So the for loop ends here. So it goes back to the inner loop and increments the column value. So column value was 0. So it will be 1 now. So 1 less than 2 is true. So it has to enter the loop again. Yes, it enters the loop again. And you have to observe this. Row is 0, column is 1. So A of 0, comma 1. A of 0, comma 1 is, so in our example, we can see A of 0, comma 1 is 20, right? So it has to display 20. Yes, it displays 20. Now observe. Column value has to be 2 now. So 2 less than 2 is false. It has to come out of the inner loop. Yes. If you see, it came out of the for loop, inner for loop, and it went back to the outer for loop because there are no more statements we have after the inner for loop. So it just saw this, and then this is the end of the for loop. So it came here, and then it went to the outer loop. Control went to the outer loop, and row is 0 now. It has to increment. So it will increment by 1. and now row will be 1. 1 less than 3 is true. This is the reason it enters into the loop. And again, once it enters into the loop, it is again like it will repeat for the columns, each column, right? So for the first column, so column 0, 0 less than 2 is true. So column will be 0, row will be 1. So we entered into the second iteration for the outer loop. So row is 1 now, 1 of 0. 1 of 0 is 30 in our case, right? So it will display that. Again, column will be incremented. So column is 1 now. 1 less than 2 is true. So it enters into this loop. 1 is, row is still 1, remember. 1 of 1. 1 of 1 is 40. All right. Now column will be incremented. This is 2. 2 less than 2 is false, right? So it will come out of this inner loop, goes back to the outer loop. Now, row will be incremented. Row is now 2. See, you can observe this in the variable section, right? So you can see row, or you can hover on your mouse on this variable for whatever you wanted to check the value while debug. So it is 2, right? 2 of, what's the column? So let's enter into the inner loop. Column is 0, 2 of 0. 2 of 0 is 50. It will display that. And for the next column, 2, 1, right? 2, 1 is 60. So add row to column 1. A of 2, 1 is 60. It will display that. Now, column will be incremented. Column is 2 now. 2 less than 2 is false. So it breaks the inner loop, goes back to the outer loop, right? Goes back to the outer loop. Now, observe. Row is already 2. So it should be incremented by 1. It increments by 1. So it will be 3. 3 less than 3 is false, right? So it should come out from the outer loop as well this time. Yes, it came out of the outer loop and the program is terminated. So this is how two-dimensional array works. Now say for example, if you wanted to print it in the matrix form. So how do we do that? So how we can do it is a system.out.print. Then we have to print it row by row, column, we can print it side by side. So if you remove ln here, so the output will be in the same line. And then once we end the inner loop, we wanted to come out of that line and have a new line. So how to display a new line is like this, println. So system.out.println actually prints a new line. So it will come to the next line and then goes back to the outer loop. Right? Once we complete the inner loop, meaning we completed one row successfully. There could be a number of columns, but once we complete the inner loop, the first row or the row is completed. Once the row is completed, we wanted to have another row displayed in a new line. So this is the reason we are doing system.out.println, right? So let's see the output. So if you see, it displays correctly 10, 20, 30, 40, 50, right? So 10, 20 is first row, 30, 40, 50, 60. But it's, it's combined because we didn't have any space. So let's leave some space here. So let's provide some space here. So this is how we can concatenate using plus within system.out.print. And then we can have some space here. This way, we can clearly see the output in our expected format, right? So this is what we are expecting in a matrix format. 10, 20, 30, 40, and 50, 60, right? So two-dimensional array. So this is simple logic. We have written, we wanted to print all the elements. So we just used outer loop and inside it, inner loop to read the columns. Outer loop is always used to for the rows and inner loop is always used for the columns. So inner for loop is used for column and inside the nested for loop inside the column. So once that condition is true, we are using the both indexes row and column and trying to print the elements. So why we had this was like if you wanted to look the values in a matrix format. So after each row, so how can we say row is completed? Once we come out of inner loop, then one iteration is done. So one iteration in the sense, in our case, it's a row, right? So once row is done, I wanted to go to the next line. So this is the reason we have kept this statement. So it goes to the next line. So and then it actually prints these values for the second iteration. Second iteration, the values will be 30 and 40. And again 50 and 60. So this is the reason we use this statement. And if you remember, if you observe, we removed ln here as we wanted to display all the column values for the same row, for the different column values, we wanted to have it in the same line. This is the reason we removed ln here. And for one column value and another column value, we wanted a space. This is the reason we just had a blank space here after displaying each column value for that particular row. So this is all about two-dimensional array. How do you read the multiple values from the two-dimensional array? And how we use the enhanced for loop? In the same way we use for a single dimensional array. So in the same way we can use for the two-dimensional array as well. So how does it work? So again, two loops, outer loop and inner loop. But this is an enhanced for loop, if you remember. So enhanced for loop, we will have array specified, and beside that onto the left, we'll have colon, and then we need to specify. Earlier, it was a single dimensional array, so we can directly read the element from it. Now, it's a two-dimensional array. So first, we will get rows from the two-dimensional array. So that we need to have it. Say for example, so R, let me indicate it with R. So R, two square braces, meaning it's a row. So I have an array, it's a two-dimensional array. So the first element of it will be a row, first row, or say for example, row. Say for example, assume it's a first row, right? Now, from the first row, I wanted to read all the elements. So enhanced for loop, we'll use R. This is the array, and we wanted to read all the columns one by one, all the columns from that row. So this is how we declare it. We have seen this is how the enhanced for loop works. We know this, like from the row, read all the columns. This is very much similar to the single dimensional array. So the only new thing will be this one. From the array, as A is a two-dimensional array now, so read each row every time. So point to first row for the first time and enter into the loop. And for that row, so traverse through all the columns of that row, and display the value of column here, right? So I'm not going to have an array A of R, T like that now, because R is, we already know R is the row, R indicates row. From that row, we are actually reading the values. So here A is an array. It is actually traversing through or reading a row each time. In each iteration, it is pointing to one row. For the first time, it will point to the first row, enters into the loop, enhanced for loop. So this R indicates the first row now. From the first row, iterate through, read all the columns is what we are seeing. So reading all the columns is, so it has to go through first 10, then 20, like that, right? So 10 and 20 will be read, and then done with this loop, inner loop. Then it goes back as there are no more columns. So it has read all the columns for the first row. So it goes back to the outer loop. Now, from the A, it will take the second row. So this indicates the row, right? So it will read the second row. As the enhanced for loop, what it says, it has to follow the order from first index to the last index, or first element to the last index. In the two-dimensional array, it actually, as per the logic we have written, it will read the next row, second row. So second row will be, so we'll get the second row, and for the second row, it will enter into the loop and it will read all the columns. All the columns in the sense 30 and 40 in this case, right? So let us execute and verify. In the same way, third row, right? So you can see the elements have been displayed. All the elements have been displayed within the enhanced for loop. Enhanced for loop, right? Now, in the same way, like I wanted to print it in the matrix form, then it is simple. Like you'll just remove ln, and after the inner for loop, you'll have a new line. So with this, what happens? Once the inner for loop is done, then it will leave a line, goes to the next line, then goes back to the next row, right? And it will print all the columns within that row. So it is simple. This loop actually iterates over columns for each row, and the outer for loop is for the rows. So for it will actually say or talk about the row. So this is for tracking the rows, and within the each row, the inner loop actually tracks columns for that particular row. Now again, so we have this space issue. So you can just have some space here after printing each column. So after displaying each column, we have some space here. And then after displaying all the columns of one row, then we'll leave a line. So we wanted to go to the next row. So we went to the next row. And we'll go back to the outer loop. We'll come up with the new row. So we'll pick up the new row. And for that row, all the columns of that row will be displayed. And once that is done, again, a new line, right? Again, it points to the new row. New row in the sense, next row. Last row. For the last row, all the columns of the row will be displayed. Once it is done, then it will leave the line and there are no more rows to read. So the outer for loop will also end. So this is how the enhanced for loop works for the two-dimensional array. All right then. So this is all about two-dimensional array. So is that clear? Is that clear? Two-dimensional array. So if you observe, we are declaring it. So int r, right? So we declared it. We declared int c. We declared it here. So this was the syntax of the enhanced for loop if you observe. R indicates row. So from the array, when we do an enhanced for loop, it will return the row. So as it is a row, it is not a normal variable. So it's a row, meaning it will have the columns as well. So we are declaring it as an array and capturing each row in this variable called R. And inside R, we'll have columns in it. So each row will have columns. So that we wanted to capture it in a variable called C. So we declare it as column C, int C, right? And then using that value here. So when we say C, it is of the current row. So first column, say for example, and again, next time, current row, second column. Like that, all the columns for that current row will be displayed. Is that clear? All right then. So in this session, this is all about two-dimensional array. This is also called as double-dimensional array. Very important concept. So we are going to use this when we are writing the Selenium scripts. So in this session, we have discussed about what array is, and what's the purpose of using array. And we have seen how to declare and instantiate the arrays, and we have seen the characteristics of arrays. We have two types of arrays, single dimensional and two-dimensional arrays. We have seen what single dimensional array is and how the elements are stored and how do we read them, how to find the size of the array, right? How to read the single value from the array, how to read multiple values using the for loop that we have seen, right? And coming to and we have also seen enhanced for loop. This was new to us, right? So we have seen how enhanced for loop works. So unlike the traditional for loop, so it will not have initialization part, it will not have condition, it will not have, increment or decrement, right? So, and this is the reason we wanted to understand when we can use enhanced for loop and when we can use traditional for loop. So we have seen, so when we wanted to traverse all the elements, we can use enhanced for loop. So in all the other cases, when you have the complex logic, we'll use the traditional for loop. And then we started with understanding two-dimensional array. So two-dimensional array is all about rows and columns. So this is called as 2D because we have a row and column. So two-dimensional. One dimension is row and another dimension is about column. So this is the reason it is called as two-dimensional array. It is called as two-dimensional array, right? So, and we have seen different operations that we can perform on two-dimensional array. So we saw this comparing with the single-dimensional array. So how to declare, what are the different ways to declare the two-dimensional array, how you can store the values into the two-dimensional array, how to find the size, and how to read the single value, and how we can read the multiple values. So multiple values, so though it seems like bit tricky, but it's very simple. It's actually a nested for loop inside another loop. So one loop is used to track the rows, and another for loop is used to track the columns for the per rows for each row, right? So, and we have seen the enhanced for loop, how to use the enhanced for loop for two-dimensional array as well. So at any point of time, whenever we wanted to use the enhancer for loop, so we use only that when we wanted to traverse all the elements into the array, be it a two-dimensional array, single-dimensional array, we use the enhancer for loop only when we wanted to traverse through all the elements. Only then we use the enhancer for loop. In all other cases, we can go for the traditional for loop. So this is all about the arrays.